limits at infinity. When x is tending to plus infinity or when x is tending to minus infinity, L is the limit which we call limits at infinity. This y is equal to L is an horizontal asymptote to the curve. For example, let us see the curve of tan inverse x. Let us see this particular portion when x is tending to plus infinity. When x is tending to plus infinity, look at the limit value. Here it is tending to plus infinity. We check the value which is pi by 2. So when x is tending to plus infinity, I get pi by 2. When x is tending to minus infinity, this side. So this side it tends to minus infinity. The value of L is minus pi by 2. A particular portion of the curve of tan inverse of x we have taken as x tends to plus infinity as it goes on and on. The limit value is plus pi by 2. Whereas the same curve tending to minus infinity, the limit value is minus pi by 2. So these things are some examples for limits at infinity. Here are some easy techniques to evaluate the limits of rational functions as x tends to infinity. You have p of x, a polynomial in the numerator, and q of x, another polynomial in the denominator. Let us check the degree of p of x and degree of q of x. If q of x, the degree of the denominator is greater, then my answer is 0. If the degree of numerator is greater, then my answer would be either plus infinity or minus infinity. Suppose degree of p of x and q of x are equal. Now we say coefficient of highest power of x in p of x, that is a numerator, divided by coefficient of highest power of x in the denominator. So we check the degree of numerator and denominator. If numerator degree is greater, my answer is either plus infinity or minus infinity. Denominator degree is greater, my answer is 0. If numerator and denominator are of same degree, write the coefficient of highest power of x in p of x and the coefficient of highest power of x in q of x. Let us divide and that is the answer. Let us proceed into some exercise problems to understand this better. Exercise 9.3, question number 3, evaluate. As I look out, let us factorize. Consider f of x is equal to 3 by x minus 2 minus 2x plus 11 divided by x square plus x minus 6. Factorizing the denominator for the second expression, I can write it as 3 by x minus 2 minus 2x plus 11 divided by minus 6 plus 6. So it is x plus 3 into x minus 2. Cross verify x into x, x square, 3x minus 2x is plus 6, 3 into minus 2 is minus 6. As we take LCM, f of x is equal to x minus 2 into x plus 3. Here x minus 2 present. What is missing is x plus 3, cross multiply. 3 into x plus 3 minus 2x plus 11. As I simplify, the denominator is x minus 2 into x plus 3. The numerator 3 into x, 3x plus 3 3s are 9. Taking minus symbol in, minus 2x minus 11. As we simplify, 3x minus 2x is x. 9 minus 11 minus 2. Denominator x minus 2 into x plus 3. As we cancel, we get 1 by x plus 3. My question is to find limit x tends to infinity f of x. F of x is now simplified as limit x tends to infinity 1 by x plus 3. And my answer is 1 by infinity. Infinity plus 3, I get infinity. My answer is 0. There is second procedure. There is minus symbol. So we can split the limit for difference. Limit of first term minus limit of second term. We recall this formula whenever I have rational expression. Check the degree of denominator as well as numerator. Denominator degree is more. My answer is 0 whenever x is tending to infinity. In this problem, the numerator degree is 0, isn't it? Because it's a constant which has degree 0. Denominator degree is 1. Here when I consider, the numerator degree is 1 and the denominator degree is 2. So here the power is 1, so degree 1. Here the power is 2, so degree is 2. Therefore, both the answers will become 0 because in both the cases, denominator degree is more. So these questions, just by looking at it, you must be able to say the answer 0 minus 0, and so the final answer is 0. A little before we did algebraic method, which I have written as method 1. And limit x tending to infinity p of x by q of x by applying direct formula, we have called it as method 2. You can check method 2 is better and easy when you derive. That is why we learn limits at infinity formula. Question number 4. Evaluate limit x tends to infinity x cube plus x by x power 4 minus 3x square plus 1. Again, it's a rational expression. The numerator as well as denominator are polynomials. Here the highest degree 3. So the numerator degree 3. Denominator the highest degree is 4. So p of x, the degree is below the degree of q of x. Whenever the denominator degree is more, when limit x tends to infinity comes, the answer is 0. Applying the formula in this case, when I compare numerator and denominator, denominator degree more and limit x tends to infinity. So I can immediately write the answer as 0. Question number 5. Evaluate limit x tends to infinity x power 4 minus 5x by x square minus 3x plus 1. Numerator and denominator are polynomials. We can very well recall this formula. Limit x tends to infinity, p of x by q of x is plus infinity if degree of p of x is greater than degree of q of x. The numerator I call p of x, the denominator I call q of x. Degree of p of x is 4 and degree of q of x is 2. Obviously, 4 greater than 2. P of x degree is greater than q of x degree, and so the answer is infinity. These are objective type questions. Instead of simplifying factorizing, you can very well apply this limit formula. Question number 6. Evaluate x tends to infinity 1 plus x minus 3x cube by 1 plus x square plus 3x cube. Again, it is a rational expression and limit x tending to infinity. I can recall this formula. Look at the highest degree. The numerator highest degree 3. The denominator also the highest degree is 3. As they are equal, let us recall. Limit x tends to infinity, p of x by q of x is coefficient of highest power of x in p of x by coefficient of highest power of x in q of x. Here, the highest power of x is x power 3 and the coefficient is minus 3. Denominator highest power is x power 3 and the coefficient is plus 3. So my answer is minus 1. Whenever the numerator and denominator is of same degree, I can just put highest power coefficient divided by highest power coefficient. So minus 3 by plus 3 will give me the answer as minus 1. Question number 7. Evaluate limit x tends to infinity x cube by 2x square minus 1 minus x square by 2x plus 1. If I directly apply limit x tends to infinity, the numerator power is more. So this is infinity. Again here, the numerator power is more. So this is also infinity. We get infinity minus infinity, that is indeterminate. So let us take LCM. Limit x tends to infinity. The denominator 2x square minus 1. Here the denominator 2x plus 1. As I cross multiply, x cube into 2x plus 1 minus x square into 2x square minus 1. So we just cross multiply as we take LCM as the product. Simplifying, limit x tends to infinity. X cube into 2x, 2x power 4, 1 into x cube, minus x square into 2x square, 2x power 4, minus x square into minus 1 is plus x square. Denominator, I can just multiply 2x square into 2x, 4x cube, 2x square into 1, 2x square, minus 1 into 2x, minus 2x, minus 1 into 1, minus 1. 2x power 4 gets cancelled. As we simplify, we get limit x tends to infinity x cube plus x square as the numerator, 4x cube plus 2x square minus 2x minus 1 as the denominator. As I check the degrees, the numerator highest degree 3, the denominator also highest degree 3. So we check the degrees are equal. Whenever the degrees are equal in a rational expression and limit x tends to infinity, our answer is coefficient of the highest degree of x here. So highest degree is x cube and the coefficient is 1 divided by coefficient of highest degree of x in the denominator. Here the highest degree is 4x cube and the coefficient is 4. So the answer is 1 by 4. Question number 8. Show that limit n tends to infinity 1 plus 2 plus 3 and so on up to n divided by 3n square plus 7n plus 2 equals 1 by 6. As we recall, the sum of the first n natural numbers is nothing but n plus 1 by 2. Denominator, we already have 3n square plus 7n plus 2. Limit n tends to infinity. As I simplify, it is limit n tends to infinity. Club the 2 to the denominator. It is 2 into 3n square plus 7n plus 2. The numerator I can multiply n into n square plus n into 1n. As we check, it is a polynomial not in x but in n. But n tends to infinity. So I can very well apply the same formula, but in the place of x we have n. So what is the highest degree? Here the highest degree is 2. So the numerator degree is 2. The denominator also the degree is 2. Whenever the numerator and denominator are of same degree, we just divide the coefficient of highest degree term. The numerator, the coefficient is 1. Denominator, already there is a 2, and now here we have the highest degree is n square and the coefficient is 3. So the answer is 1 by 6. Can I keep this 2 as it is? Yes, because this is unaffected by the limit. Keep the 2 as it is. Check only these two terms. Here the coefficient is 1. Here the coefficient is 3. So 1 by 2 into 3, I get 1 by 6, and that is the answer. Second subdivision. Show that limit n tends to infinity, 1 square plus 2 square and so on up to 3n the whole square, divided by 1 plus 2 plus and so on up to 5n into 2n plus 3 is 9 by 25. The numerator, sum of the squares of the natural numbers. Let us recall the formula. 1 square plus 2 square and so on up to n square is n into n plus 1 into 2n plus 1 by 6. For the numerator, wherever n comes, I have to put 3n. It ends with 3n. For the denominator, we have 1 plus 2 plus up to 5n. We recall 1 plus 2 plus 3 up to n is n into n plus 1 by 2. Here, n is 5n. So we'll just apply in this formula. The question is limit n tends to infinity. 1 square plus 2 square and so on. 3n the whole square. Denominator 1 plus 2 up to 5n into 2n plus 3. As I simplify, it is limit n tends to infinity. For the squares, this is the formula, but wherever n comes, I must put 3n. So this will be 3n plus 1, 2 into 3n plus 1. The whole thing divided by 6. Denominator 1 plus 2 up to 5n. So we'll apply in this formula, but wherever n comes, 5n. So it is 5n plus 1 divided by 2 into 2n plus 3. As I simplify, I can cancel n and n. 3 cancels here 2 times. This 2 in the denominator and 2 in the denominator can very well get cancelled. The remaining terms, I get limit n tends to infinity. 3n plus 1 into 2 into 3n, 6n plus 1. Denominator 5 into, as it is, 5n plus 1 into 2n plus 3. As we simplify, the numerator we can very well multiply 3n into 6n, 18n square, 3n into 1, 6n into 1, 1 into 1. Denominator 5 as it is, 5n into 2n, 10n square, 5n into 3, 15n, 1 into 2n, 1 into 3. As we check, the highest degree is 2. Denominator also the highest degree is 2. So we recall the formula. Limit x tends to infinity p of x by q of x. When they are of same degree, the numerator degree is 2. The denominator degree is also 2. And instead of x, we have n in this question. So the formula is coefficient of highest degree term. Highest degree term 18n square. So the coefficient is 18. Denominator 5 will be retained as it is. coefficient of highest degree term. Highest degree term is 10n square and the coefficient is 10. As I simplify by 2 table, it is 9 by 5 and we get 9 by 25 and that is the result to be shown. Hence the problem.